Hello Math 45 students. Let's continue with Chapter 2, page 16, section 2.5 Quadratic Equations. So solving quadratic equations, we can do that several ways. One of my favorite ways is by factoring. Hopefully you guys remember how to factor. We have the GCF, or we pull out a leading negative. If there's 4 terms, then we factor by grouping. If there's 3 terms, some students like to use the AC method, and if there's 2 terms, then the difference of squares or the sum or difference of cubes. And if you tried everything and nothing can factor, then we're going to say that it's going to be prime. So once your quadratic equation is factored, you can use the zero product property. The zero product property, what it states is that if you multiply 2 numbers together, even though you don't know what that is, and it's equal to 0, then one of those numbers has to be equal to 0, because anything times 0 is equal to 0, okay? So let's go ahead and let's think about this in this first example. So the first thing I want to do is I want to look at the leading coefficient. The leading coefficient in our first problem for number 1 is, or for problem A, is 1. Because it is 1, so it's a 1x squared plus x minus 6 is equal to 0, that's going to help us to factor this a lot nicer. So we have that A is equal to 1, our B is equal to 1, and our C is equal to a negative 6. So when we do the AC method, then we have our A times C up on top, and our B value up on the bottom. So here, A times C, 1 times negative 6 would give you a negative 6. And our B value is a positive 1. So what you want is you want 2 numbers that satisfy the following, that they multiply to A times C, but it also adds to the B value. So here you want 2 numbers that multiply to 6 and adds to 1. So let's think about all of the factors of 6. I have 1 times 6 and 2 times 3. So here, to get our 2 numbers that multiply to A times C and adds up to the B value, well, 2 times 3 could give you a negative 6 and adds up to a positive 1 if the 3 is positive and our 2 is negative. And because our leading coefficient is 1, then I can put it right into my double parentheses. So I have that this is going to equal my middle terms here. So those middle terms, I'm going to have x minus 2 and x plus 3 equal to 0. So now I said each parentheses equal to 0. So x minus 2 is equal to 0. So then x is equal to 2. X plus 3 is equal to 0. So x is equal to negative 3. So now I have my 2 answers. X is equal to 2 and x is equal to negative 3. Alright, so now we're going to do the exact same thing for B. So here, what we want to do is we want to look at our A, B, and C values. So our A value is 4, our B value is 15, and our C value is equal to a positive 9. So if we do the A times C and our B values, well, let's look at what those values are going to be. So A times C, 4 times 9 is going to give me a positive 36, and our B value is 15. So again, we want 2 numbers that are going to multiply to 36 that adds up to 15. So when I think about it, I have 1 times 36, and I also have 3 times 12. And that 3 times 12 will give me my 15. So I would have a positive 3 and a positive 12. And here you want to be careful, because the leading coefficient is not 1. So since the leading coefficient is not 1, then I am going to have to rewrite this equation and do a factor by grouping. So I'm going to rewrite it as my 4x squared plus 3x plus 12x plus 9 equal to 0. So what ends up happening is that these two middle terms substitute that middle term that I have up here. So now when I do my factor by grouping, I'm going to look at the first two. The first two, what they have in common is an x. So I'll be left with a 4x plus 3. The next two are going to have a 3 in common, so I'm left with the 4x plus 3. So because I have this parentheses the same as that parentheses, then I can factor that out, my 4x plus 3, and then your leftover to be x plus 3 equal to 0. So now I have x plus 3 is equal to 0, so x is equal to a negative 3. I also have my 4x plus 3 is equal to 0, so then 4x is equal to negative 3, and x is equal to a negative 3/4. So I have that x is equal to negative 3/4, and that my x is equal to a negative 3. So those are going to be my two answers for part B. Now I'm going to look at letter C. Well, for letter C, I have only two terms. So this is actually a difference of squares. And hopefully you remember how that factors. So if I have x squared minus 9 is equal to 0, you can think of it as x minus 3 squared. The reason is because x times x is x squared, and 3 times 3 is equal to 0. So now I know this is going to be x plus 3 and x minus 3 equal to 0. So I have x plus 3 is equal to 0. So x is equal to a negative 3. Also, x minus 3 is equal to 0. So x is equal to a positive 3. So I have x is equal to negative 3. And I have x is equal to a positive 3. All right. So now for part D. I have three terms, but I also see a lot of x to the third power, x squared, and x. And it's also negative. So my GCF is going to be different. My GCF to start with is going to be a negative x. So I'm going to factor a negative x out from everything first. So I have my negative x. So I would be left with a 3x squared plus a 5x plus 2 all equal to 0. So now I'm not going to forget about that negative x, but I'm going to come back to it. Okay, and so I want to rearrange this. So I have that my a is equal to 3, my b is equal to 5, and my c value is equal to 2. So I have my a times c, and I have my b value. So a times c, 3 times 2 will give me a 6. My b value is a 5. So that would give me a positive 3 and a positive 2 for two numbers that multiply to a 6 but adds to a positive 5. So now I'm going to rewrite this. I'm going to have my 3x squared plus 3x plus 2x plus 2 is equal to 0. And again, this middle term replaced that middle term here. So now when I factor, I'm going to factor the first two. It looks like it's a 3x. So I'm left with an x plus 1. Plus 2, I'm left with an x plus 1. Perfect. So the common parentheses would be an x plus 1, and I have a 3x plus 2 equal to 0. So now I have x plus 1 is equal to 0, so x is equal to negative 1. I have 3x plus 2 is equal to 0, so my 3x is equal to a negative 2, so x is equal to a negative 2/3. So my two answers, I have x is equal to negative 1, and x is equal to negative 3, negative 2/3, and I can't forget this answer over here. that negative x is equal to 0, so my x is equal to 0. So I actually end up getting 3 different answers here. So you can't forget that GCF in the very beginning. Okay. Now we're going to move along to the square root property. So for the square root property, it says if you have an x squared equal to a number, then that number is going to be plus or minus the square root. So for example, if I were to have this x squared is equal to 8, well, to undo the square, you square root it. But when you square root it, don't forget the plus or minus. So I have x is equal to plus or minus the square root of 8. And if you want to think about this, this is something that we've done in previous classes, previous algebra classes. If I have 8, I can rewrite this as 4 times 2, which is 2 times 2. So 8 is really 2 squared times 2. And we really want to make sure that that exponent matches the index. So I really have that x is equal to plus or minus the square root of 2 squared times 2. The reason we do that is so that this 2 squared can jump out, and I can rewrite it as x is equal to plus or minus 2 square root 2. And that is going to be my final answer, that x is equal to plus or minus 2 square root 2. So let's go ahead and look at part B. So if I'm looking at part B, then I'm going to subtract 1 from both sides. So now I have a 4x squared is equal to a positive 6. Now I'm going to divide by 4 on both sides, so that I have x squared is equal to 6 divided by 4. And remember that square tells me to square root both sides, and don't forget the plus or minus. So x is equal to plus or minus the square root of 6/4, which really tells me that this is going to be plus or minus the square root of 6 over the square root of 4, which is going to be the square root of 6, and the square root of 4 is 2. So this is really saying that we have my final answer as x is equal to plus or minus the square root of 6 over 2. So that is what I get as my final answer. Now I'm going to look at part C. If I'm looking at part C, I'm going to rewrite it. So 3x minus 4 squared is equal to a 15. So I'm going to divide by 3 to get rid of it, so that I have an x minus 4 squared is equal to 5. From there, I'm going to square root both sides, and don't forget the plus or minus, so that x minus 4 would be equal to plus or minus the square root of 5. Now, you want to make sure that that 4 is put on the other side in the right direction. It's always going to be in front of the plus or minus. So x is equal to 4 plus or minus the square root of 5. So that is going to be my final answer. Now, in the next section, we want to make sure we know how to complete the square. With completing the square, sometimes that helps if we do not have something that factors nicely. And so what we do, we kind of put this into a formula. So let's assume that our original equation is in the ax squared plus bx plus c. That is going to be where we start. So then what we want to make sure that we do is that we identify our b value, our b divided by 2 value, and of course our b divided by 2 squared value. So really, it just comes to what's b, divide it by 2, and then square it, and then it kind of fits nicely into this formula that we have in step 4. So let's put that into play. So I'm looking at x squared minus 3x minus 5 is equal to 0. So what I want to do is I want to identify my b value. So here, my b value is going to be negative 3. So I know I'm going to rewrite this as x minus Now I'm going to have over here my b divided by 2 value squared equal to, and don't forget that you moved this -5 to the opposite side. So when you do that, it's by adding. So now it's a +5. And don't forget that you're going to have plus your b divided by 2 value squared. And I am getting that from my step number 4. Okay, so this is the equation that I'm really focusing on right in here. So now that I have that, I am going to put this into play. So I know that my b divided by 2 value, well, my b value is -3. So when I divide it by 2, it's just a -3/2. So then my b divided by 2 squared would just be a -3/2 squared. So -3 times -3 is 9, and 2 times 2 is 4. So now that I have all that, I can plug it in. So I'm going to have x, and in here I'm going to have my -3/2 squared is equal to 5 plus my 9/4. Now from here, I'm going to combine like terms, or simplify just a bit. So I have my x minus my 3/2 squared, and 5 plus 9/4. You can do this on your calculator or not. I have 29 over 4. So to undo the square, I'm going to square root both sides and not forget the plus or minus. So I'm left with x minus my 3/2 is equal to plus or minus the square root of 29 over the square root of 4. And of course now what's left to do is I'm going to add the 3/2 to the other side, so that x is equal to a positive 3/2 plus or minus the square root of 29, and the square root of 4 is 2. So that is how I do the completing the square. Okay. So we're going to take this concept and work on it for part B. So for part B, the first thing we want to do is make sure that that leading coefficient is 1. So make leading coefficient equal to 1. If it's not equal to 1, then it's really going to be very difficult here. So what I want to do by doing that, I'm going to divide everything by a 2. So that will give me an x squared minus a 6x is equal to a positive 13. So now I can identify my b value. My b value is now a 6. So when I divide that by 2, my b divided by 2 value would be 6 divided by 2, which would be 3. So my b divided by 2 value is now equal to 3. So if I were to square that, it would just be 3 squared, which is 9. Okay, so now I have my outline. I'm going to have x minus my b divided by 2 squared equal to 13 plus my b divided by 2 squared. And I already calculated my values over to the side. So I have x minus 3 squared is equal to 13 plus, and in this case, my 9. So now I will have x minus 3 squared, and 13 plus 9 is going to give me 22. And I need to square root both sides and not forget the plus or minus. So I have x minus 3 is equal to plus or minus the square root of 22. And I'm going to add 3 to both sides, so I have 3 plus or minus the square root of 22. So x is equal to 3 plus or minus the square root of 22. Okay. Now, the next section is going to talk about the quadratic formula. So for the quadratic formula, that is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. So really, once we identify our a, b, and c value, we just plug it into the formula. So let's go ahead and do that. So we have that our a is equal to 1, our b is equal to negative 5, and our c value is equal to a positive 1. So when I plug it into my formula, which is my negative b plus or minus b squared minus 4ac all over 2a. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c over 2 times my a value. So now all I have left to do is just plug in my values. So I have a negative 5 for my b value. I have 1 for a and 1 for c. So when I simplify, I'm going to get that x is equal to a positive 5 plus or minus, and you can do this on your calculator, right? Negative 5 squared minus 4 times 1 times 1. So 25 minus 4 gives you 21 over 2. And that is what the x is going to equal. For part B, we have the exact same process. So, okay, we have that our a value is equal to 1, the b value is equal to 1, and our c value is equal to 2. So since I already know my formula, I know it's negative b plus or minus the square root of b squared minus 4a times c all over 2 times a. So the values that I'm plugging in, my b value is 1, and I have my a value as 1, and my c value as 2. So I'm going to have a negative 1 plus or minus the square root. Now if I have 1 squared minus 8, that's going to give me a negative 7 over 2. So just know that whenever I have a negative inside the square root, then that means it's going to be imaginary. So I know I'm going to have an imaginary number. So x is equal to negative 1 plus or minus I square root 7 over 2. So now I have my imaginary number. Okay. Now, if we look at that quadratic formula, what I can do is I can kind of zero in on just the stuff underneath the square root. Well, that thing inside the square root would just be called the discriminant. So let's think about this. If I were to have, negative b plus or minus b squared minus 4ac all over 2a. So the discriminant is just that thing that's going to be underneath the square root. Wouldn't it be nice to know whether or not you're going to have an irrational number, something that's going to be imaginary, or no solutions? Well, you can. It all depends on the value of the discriminant. So when that value is equal to 0, you have one rational solution. If it's going to be a positive number, something that's greater than 0, you'll have 2 rational solutions. If it's greater than 0 and not a perfect square, then it'll be 2 irrational solutions. And if it's a negative value, meaning it's less than 0, then you have 2 complex solutions. So let's go ahead and think about this for part A. So I'm going to go ahead and identify my values. I have that A is equal to 1, B is equal to 4, and my C is equal to 4. So the discriminant that I'm thinking about is just my B squared minus 4A times C. So the values that I'm plugging in is my B, which is 4, my A, which is 1, and my C, which is 4. So here I would get a 16 minus 16, which is a 0. So if it's exactly equal to 0, then it tells me that I have one rational solution. And so that is going to be my final answer. So let's do the exact same thing for part B. I have that A is equal to 8, B is equal to 14, and C is equal to a positive 3. So I still have my B squared minus 4AC. So I have B squared minus 4 times my A times my C value. So my B value is 14, my A value is 8, and my C value is 3. So I'm going to have my 14 squared, which is 196, minus, well, 4 times 8 is 32, times 3, which give me 96. So 196 minus 96 is 100. So that is a positive perfect square root. So I'm going to say that I have two rational solutions. And the way I did that was by looking at my table up above. So now let's look at part C. So again, I'm just going to be identifying my A and B and C value. So my A is 3, B is negative 5, and C is equal to a negative 2. So I have my B squared minus 4A times C. So when I plug in my values, I'm going to get my B, which is negative 5, my A, which is 3, and my C, which is negative 2. So I'm going to have that this is, well, negative 5 times negative 5 is 25, and 4 times 3 is 12, times negative 2. So actually, let's just put this all together on my calculator. So 25 minus 4 times 3 times 2 would actually give me a positive 49. That is a perfect square root. So it's just like part B. So I'm going to say I have two rational solutions. Okay. And now for that last one. So I'm going to have that A is equal to 3, B is equal to negative 10, and C is equal to a positive 15. So when I plug it in, my B squared minus 4 times A times C. So I know that I'm going to plug in my B value, which is negative 10, my A value, which is 3, and my C value, which is 15. So negative 10 squared is 100, and then 12 times 15. So that is going to give me a total of negative 80. So negative 80 is less than 0. So what that tells me, since it's a negative number, that I'm going to have two complex solutions. And remember, I got that by my chart, right? So I have something that's less than 0. So that means I have a negative number. So I have two complex solutions. And that is what I wrote, my two complex solutions. Okay. And of course, we have to know about the Pythagorean Theorem. When I'm looking at the Pythagorean Theorem, we know that A squared plus B squared is equal to C squared, where A and B refer to the legs of the right triangle and C is the hypotenuse. You can always think of C as the hypotenuse because it's directly across from that little square. And the square, what that represents is a perfect 90-degree angle, okay? So let's see, it says find the length of the missing side of the right triangle. So we know that my C value here is 12. So I know that if I have my leg squared plus my leg squared, that is going to equal to my hypotenuse squared. So I'm going to have 4, that's a leg, plus my other leg, which is A, is equal to my hypotenuse squared, which I have as 12. So I'm going to rewrite this as a 16 plus A squared, and 12 times 12 is 144. So I'm going to subtract 16 from both sides. So 144 minus 16 is going to give me 128. Because that's a squared term, to undo the squared term, I'm going to do the square root plus or minus. So I'm going to have that A is equal to plus or minus the square root of 128. And really, because I'm talking about length, length can't be negative. So even though the algebra is correct with saying the plus or minus, because this is length, I don't consider the negative at all. So really, A is just going to be equal to the square root of 128. Now, of course, you can put that into your calculator if you wish, so that you have the square root of 128 is equal to 11.31370. So let's round that to the nearest tenth. So that would be the first decimal. So that would be 11.3. So then that would be my final answer. Okay. So now for the next example, it's a word problem, but it's still the same process. So it says a leg of a right triangle measures 4 inches. The other leg measures 3 inches. What is the length of the hypotenuse? So I at least know it's a right triangle. So I know that I can draw that. And there's a square because that represents the 90 degree, the right triangle. A right triangle represents its 90 degrees, so it's that little square there. And so a leg measures 4 inches. So you're just like, okay, perfect. It's telling me that one of the sides is 4. The other leg is 3 inches. Okay, so it's asking me what is the hypotenuse. That's the I don't know. So let's go ahead and call that C. So I know that I'm going to have leg squared plus leg squared is equal to my hypotenuse squared. So the leg is 4, the other leg is 3, and the hypotenuse I'm calling C. So I'm going to have 16 plus 9 is equal to C squared. So that's going to give me 25 is equal to my C squared. And because, and only because I am dealing with measurement, I'm only going to take the positive of this, so that that 5 is equal to my C value. So I can say that my hypotenuse is going to equal to 5 inches. Okay. And that is the end of section 2.5. If you guys have any questions, please email me.